Hi class, here is your worked out problems video for section 3.9, numbers 1, 4, 21, and 25. Okay, let's see, we have, for 1 and 4, I made a chart because for 1 and 4, they both use the same chart. They give you a list of X's for 1 and 4, where they give you the function. I am assuming you can fill in the second row. All they're asking you to do is take the X of 1.9 and put it into the function and output the value here. Put in X of 1.99, output the value here all the way across. So you know how to do function values. It is the same with f of x, the square root of x, right? You are just putting each x into the actual function to fill in the first row that's open. I think what you need is they ask you to fill in this row, which is t of x, which would be the equation of the tangent line to this function at this point, and pop the x's into the tangent line at this point. Okay, so let's do that for number 1 and let's take a look. So the equation of my tangent line then for the function f of x equals x squared. First of all, they gave me the point 2, 4. So I'll put the 2 here for C and here for C and here for 4, right? For f of C, 4 plus. So all I need now is the derivative of the function at 2 right? Just checking to make sure I did that right. So all I did was put in the 0.24, right? That's our starting point on our tangent line. So of course, all I need is the derivative of the function at 2. I can do that. Here's my function x squared, right? And so its derivative is 2x, right? And of course, I'm going to evaluate that at 2. 2 times 2 is 4. Okay, so now all I'm going to do is I'm going to go across the row here. I'm going to put in an x of 1.9 and output an answer and put it here. I'm going to put in a 1.99 into my tangent line and output the answer and put it here. Of course, when I put in a 2, I get a 4, right? And all the way across for 2.01 and 2.1. Again, the easy way I find to do this is rather than typing the tangent line over and over, I'm just going to put my tangent line in my y1, right? X minus 2. So all I did was put my tangent line in my y1, and I'm going to graph it, zoom 6, right there it is. And now I'm going to do second calc, right? Well, it's second trace, and it gives me calc. Right, so second trace, and I'm going to put in number 1. I'm going to keep doing number 1. I hit the value button and it says, hey, what x do you want? Here's my x's. I'm going to put in a 1.9 and I get a 3.6. I'm going to do calc again in value and put in 1.99, 3.96, 2.01, 4.04, 2.1. Isn't that nice and quick? There we go, 4.4. Okay, any questions on filling that bottom row out? Give me an email. Okay, let's see. Let's do the same thing for number 4. Right, so let's clear the chart here. Notice when I put a 2 in, I get a square root of 2 out, right? I already know that. I can fill that in. Okay, same thing, equation of a tangent line. So let me I don't want this to distract you. There we go. We're going to go above. The equation of the tangent line then would be, I'm going to put in the 0.2 in the square root of 2, right? Good, so all I did was put in my C and my f of C. C here and f of C there. Oh, It's a 2. There we go. So all I need now is the derivative of the function at 2. And I already know how to do that. So I know that the derivative of the square root function, I have it memorized because it happens all the time, is 1 over 2 square roots of x. And I'm going to put a 2 in there. So not pretty, but it's 1 over 2 square roots of 2. I don't really feel a need to change it. You know, I'm just going to put it into my calculator. 1 over 2 square roots of 2, right here. That's and I'm going to put that on my y equals very carefully, making sure it's really doing what I want. So that would be the square root of 2 plus, I'm going to use an ND here, 1 over 2 square roots of 2. And then that is times x minus 2. There we go. I'm going to do a zoom 6. There we go. Now all I have to do is keep hitting the calc button and a value and put those x's in, right? So let's see. 1.9, 1.379, 1.99, 1.411, 2.01, 1.418, 2.1, 1.44, 1.450. There we go. Let's move to 21. On number 21, they gave a graph of f, and they show a tangent line at the point 2,1. And they also show that that tangent line does hit the x-axis at 1, 0. The directions say use differentials. I cross that out. Use the tangent line to approximate f of 1.9 and f of 2.04. So that's what a tangent line does, right? It outputs, given a starting y and a change in y, it outputs a new y. It outputs a new function value. So all I'm going to do is write the equation of the tangent line and then use it, right? So here's my equation of the tangent line. The tangent line starts at the point 2,1. There we go. All I need now is the derivative of f at 2. The derivative of f at 2, a derivative is a tangent line it's the slope of the tangent line at 2. That's what a derivative is, a slope at 1 point. So I need to look at my tangent line that they drew for me and put the slope in. It's obviously positive, right? And when you notice, if you go over 1, so you could, use the slope formula there, but I see I go right 1, up 1. That's a slope of 1. There we go. So now all I do is to figure out f of 1.9, I just put it in right there. 1 plus, I don't really need the slope of 1. 1.9 minus 2. 1.9 minus 2 is a negative 0.1 plus 1 is 0.9. Let's try f of 2.04. That's 1 plus 2.04 minus 2. That's 0.04 plus 1, 1.04. There we go. 25 asked the same question, gave different information. On number 25, the graph they give you is of the derivative of g, not of a function. It's of a derivative. So what they're trying to tell you, this point that they gave you, is there is some function g that at an x of 3, its derivative is a negative 1/2. We don't have to figure it out like we did here. They give it to you, okay? Now they say, also in bold, it says that g of 3 is 8. They give you information about the original function, that it starts at an x of 3, the value of the function is 8, okay? And it says use differentials, I crossed it out, use differentials, use linear approximation two different ways. They'll say it on the AP exam: tangent line, linear approximation. Use linear approximation to find G of 2.93 and G of 3.1. Now, I know they have G's, but I always write the equation of the tangent line the same way so that it won't confuse you. Hopefully it doesn't. So I'm going to write the equation of the tangent line, and they say that G of 3 equals 8, right? So that's my starting point. You're welcome to put G's if you want. Okay, and now what I need is the derivative of the function at 3. They gave it to me. It's right here, right? The derivative of the function at 3 is a negative 1/2, right here. They literally on a graph handed you that information. Okay, now what do they want you to do? G of 2.93. That's 8 plus, and I'm going to put in 2.93 right here. And so that is a negative 1/2. I'll call that negative 0.5. I'm going to switch to decimals here. 2.93 minus 3 is a negative 0.07. Right? And so we can get our final answer there. Someone's coming in. Is 8.035. I feel I should have done that on my own, just so you know. There we go. And then G of 3.1. Right? Value starts at 8. Plus the slope is negative 0.5. Notice here when I put in a 3.1, I get a 0.1, right? And our final answer is 7.95. There we go. There you go. Please, I'll post this. Let me know if you have any questions.